Hi, my name is Ritindi Maurid Anna William Runga and my metric number is 156358. In this video, I will explain about the differences, commonalities, and scientific logic of the modern perspective between mechanical pulping and chemical pulping. The first difference between mechanical pulping and chemical pulping is the completion of the pulping. In mechanical pulping, it is the extent of pulp refinement and estimated by specific freeness. Freeness is the ease with which water leaves the fiber mat formed on a wire mesh from a dilute slurry. While for chemical pulping, the completion measured from level of lignification occurs. The amount of potassium permanganate solution consumed by 1 gram of air-dried pulp in an acidic medium. The potassium permanganate is reacted with lignin and oxidized compound at time. The second difference is the percentage of pulp yield. Mechanical pulps has high pulp yield, which is 95%, which at the same time means that all the lignin is still present in the pulp and paper. Meanwhile, chemical pulps has lower yield, which is 45%. It is all due to the separation of wood chips into their components of cellulose, hemicellulose, and lignin, and retains the cellulose fibers while rejecting most of the rest. Therefore, the yields are less than 50%. The third difference is pulp properties. Mechanical pulps has short, weak, unstable, high opacity fibers and good print quality, while chemical pulps has long, strong, and stable fibers. Now, we are looking at the commonalities between mechanical pulping and chemical pulping. The first commonality is the environmental issues. For mechanical pulping, it causes noise pollution. The three most damaging sources of noise pollution in an industrial setting are machinery, construction, and vehicles. On the other hand, chemical pulps cause air pollution. The main components of pulp mill-related pollution are chlorine and chlorine-based materials, sulfur, hydrogen sulfide, and sulfur dioxide. In kraft pulping, which is also known as sulfate pulping, it produces chlorine and compounds of chlorine that are used in the bleaching of pulp. The second commonality is both mechanical pulping and chemical pulping are undergoes bleaching and drying technique. The purposes of bleaching are to increase the brightness and to remove the residual lignin. Meanwhile, for drying, it can help lower the cost of transportation and storage by removing unnecessary liquid volume in a material. The third commonality is both depend on refiner. It assists fibrillation that turn in improve interfiber bonding. Now we are looking at the last part, which is the scientific logic of the modern perspective. For mechanical pulping, at the beginning, they were using stone ground wood to remove sheaves, which is the fiber bundles. However, stone ground wood is not enough to separate the cellulose fibers. Then, the refiner has been invented and replaces all stone ground wood by 1990 at North America. The refiner mechanical pulping has high efficiency to separate cellulose fibers due to heat of friction, and it makes the lignin more softened. The pulp strength has decreased and the labor cost has increased due to the replacement of stone ground wood to refiner mechanical pulping. Now, we are looking at the scientific logic of the modern perspective for chemical pulping. Soda pulping is one of the oldest pulping concepts made by Xylon. The concept is to modify lignin by using sodium hydroxide. However, it is not complete and there are some deficiencies in this concept, for example, difficult to bleach and it produces dark pulp. To overcome this problem, kraft pulping, which is also known as sulfate pulping, has been invented as the extension of soda pulping. Kraft pulping are using sodium hydroxide and sodium sulfide as the active ingredient. Moreover, kraft pulping has some advantages, for example, chemical recovery possible and good pulp strength. That's all from me. Thank you for watching.